Good morning or good afternoon, everyone. Welcome. It is wonderful to see so many of you here today. And I want to start by saying something genuinely meant. Thank you for being here. In a world full of competing demands on your time and attention, choosing to be in this room, engaging with these ideas, is already a meaningful decision. And I think by the end of today, you will understand exactly why. My name is Professor Amin Beheshti. I am the director of the Center for Applied Artificial Intelligence here at Macquarie University and the founder of Collective Learning AI. The goal of this course is to introduce artificial intelligence by first building a clear understanding of human intelligence and then showing how these same principles, learning, reasoning, and problem solving, are translated into computational systems. Before we can understand artificial intelligence, we first need to understand intelligence itself. At its core, intelligence can be defined as the capability to acquire and apply knowledge and skills in order to accomplish a process. Let's unpack this definition because each key word carries important meaning. First, let's start with process. A process is a set of related tasks or activities designed to achieve a particular goal. In fact, almost everything we do as humans involves a process. When you wake up in the morning and make your bed, there is a process. When you prepare a cup of coffee, there is a process. When you enroll in a university unit, apply for a loan, or complete a task at work, there is also a process. This is why processes are so important. We have many types of processes, including personal processes and business processes. In organizations, business processes are especially important because they form the core of how organizations operate and deliver value. The second important keyword is knowledge. Knowledge can be understood as the information and understanding we gain through experience, education, and observation. Think about a newborn baby. As the baby grows, the education system, from childcare to kindergarten and primary school, helps them develop general knowledge. They learn how to identify animals, shapes, colors, numbers, objects, and patterns. These are simple examples of knowledge units that are gained over time. The next key word is skill. Skills are more about what we can actually do with our knowledge. They involve cognitive, practical, and applied abilities. For example, in the education system, high school and university courses help students develop more specialized skills. Someone who wants to become a doctor needs a particular skill set. Someone who wants to become a lawyer, engineer, designer, or data scientist needs a different skill set. These skills are built on top of general knowledge and allow people to perform specific tasks and roles. The final key part of the definition is the capability to acquire and apply. This is very important because intelligence is not only about having knowledge, it is also about being able to learn new things, apply what we know, solve problems, think critically, and adapt to new situations. This is where intelligence connects to creativity, reasoning, and decision making. So, when we say intelligence is the capability to acquire and apply knowledge and skills to accomplish a process, we are really talking about a combination of learning, understanding, action, problem solving, and adaptation. This foundation is essential before we move on to understanding artificial intelligence. Now that we understand what intelligence is, let's go a little deeper because intelligence is not just one thing. It actually has three distinct dimensions. And I want you to think about these in terms of your own life journey because I think that will make them very real and very relatable. Let's start with analytical intelligence. Think back to primary school. What were you doing there? You were learning a language. You were building your vocabulary, your grammar, your ability to read and write. You were developing memory, attention, and the ability to observe the world around you and make sense of it. This is analytical intelligence, and it is fundamentally about knowledge. It is about acquiring information, storing it, and being able to recall and apply it. The what of intelligence. What do I know? What does this mean? What are the facts? Without this foundation, nothing else is possible. You cannot reason about something you do not understand. You cannot make decisions without information. Analytical intelligence is the base layer, and for most of us, we spend our primary school years building it. Now, on top of that, we build cognitive intelligence. As you moved into high school and then into undergraduate university, your education shifted. It was no longer just about knowing things, it was about doing something with what you know. You were being asked to compare, analyze, evaluate, make arguments, weigh up options, and arrive at decisions. This is cognitive intelligence, and it is fundamentally about decision making and choosing the best next steps. It is the how of intelligence. How do I apply what I know? How do I solve this problem? How do I choose between these options? A business manager using cognitive intelligence looks at market data, weighs up risks, considers alternatives, and makes a strategic call. A doctor uses cognitive intelligence to assess a patient, consider possible diagnoses, and decide on a course of treatment. This is the intelligence that drives execution. And then at the very top, we have generative intelligence. This is where things get truly exciting. Generative intelligence is built on top of both analytical and cognitive intelligence. It is the capability to take everything you know, everything you can reason about, and use it to create something entirely new. Now, this is where it becomes particularly interesting. Intelligence is the driving force behind innovation. Every single innovation we have as humans, the engine, the microprocessor, the iPhone, the protein folding AI that won the Nobel Prize, every one of those was the product of generative intelligence. Someone didn't just know things. They didn't just decide things. They imagined something that didn't yet exist and then brought it into the world. This is the intelligence of ideation, creation, innovation, critical thinking, and problem solving. And this is precisely why research degrees at universities focus on developing this level of intelligence. A PhD is not about learning more facts. It's about training your mind to push past the boundaries of what is already known and generate something genuinely new. Now we can bring all these aspects together and revisit our definition of intelligence. Intelligence is the capability to acquire and apply knowledge and skills in order to accomplish a process. Now, this is the interesting part. As humans, we have used our intelligence to create many innovations, but one of our most remarkable innovations is something very different: the artificial version of our own intelligence. This is a transformative innovation that is changing almost every aspect of our lives. But first, let us define AI properly. Artificial intelligence is the development and implementation of computer systems or machines that possess the capability to acquire and apply knowledge and skills in order to accomplish a process. What you may notice here is that the definition of AI is very similar to the definition of intelligence we discussed earlier. Now that we understand what artificial intelligence is, let's look at what it actually looks like in the real world. And I want you to pay close attention here, because what you are about to see is a direct mirror of those three types of human intelligence we discussed earlier. Remember, we talked about analytical, cognitive, and generative intelligence. We said they build on each other like floors of a building. Well, look at the diagram on the right of this slide. There they are again. And around it, you'll see real AI systems that each of us already uses, mapped directly to each type. Starting with analytical intelligence, the data layer. Analytical intelligence in humans was about acquiring knowledge, understanding language, recognizing patterns, and making sense of information. The AI equivalent of this is analytical AI, systems that are built to process, analyze, and extract meaning from enormous amounts of data. Think about Google search. Every time you type a query, an AI is analyzing billions of web pages and ranking them in milliseconds. Think about the Netflix recommendation system. It analyzes your viewing history, compares it to millions of other users, and predicts what you want to watch next. Think about credit scoring. AI analyzing your financial history to assess your risk profile, or IBM Watson Analytics processing vast data sets to surface business insights. These systems are doing what analytical intelligence does, which is understanding the data, taking in information, finding patterns, and making sense of the world. This is the foundation. Without this layer, nothing else is possible. Moving up to cognitive intelligence, the decision layer. In humans, cognitive intelligence was about decision making, taking what we know and choosing the best next step. The AI equivalent is cognitive AI, systems that don't just analyze information, but actively make or recommend decisions based on it. Think about Google Assistant, Siri, and Alexa. They don't just find information, they interpret your intent, reason about what you need, and respond accordingly. Think about autopilot in a Tesla. It is continuously processing its environment and making thousands of micro decisions every second to keep the car safely on the road. Think about Microsoft AI Tutor, adapting its teaching approach based on how a student is responding, or Google Co-Scientist, which we saw earlier solving a superbug problem in 48 hours by reasoning through a complex scientific challenge. These systems are doing what cognitive intelligence does, evaluating situations, weighing options, and determining the best course of action. And finally, generative intelligence, the creation layer. This is where it gets truly remarkable. In humans, generative intelligence was the highest level, the ability to create something entirely new. Ideas, innovations, inventions, the things that have driven all of human progress. And now, for the first time, we have AI that operates at this level too. Think about ChatGPT, generating human quality text, answering complex questions, writing essays and code. Think about Dolly, generating entirely original images from a simple text description. Think about GitHub Copilot, writing software code alongside human developers. And AlphaFold, generating predictions of protein structures that scientists had never seen before, earning a Nobel Prize. These are not systems that retrieve or decide, they create. And that is what puts them in the same category as the highest form of human intelligence. So here is the big picture I want you to walk away with from this slide. AI is not one single thing. Just as human intelligence has different layers and dimensions, AI exists on a spectrum, from systems that analyze data, to systems that make decisions, to systems that generate entirely new things. And just as we said with human intelligence, these layers are cumulative. A generative AI like ChatGPT could not exist without the analytical foundations that came before it. Every layer depends on the one beneath it. Now look at the difference between the digital and physical worlds. We can now enable AI to enter the real world. Now look at the right side of the diagram more carefully. You will notice two words, digital and physical. For most of its history, AI has lived entirely in the digital world. It processed text, analyzed data, and recognized patterns in images on a screen. Powerful, but contained within computers. But now, AI is crossing into the physical world. Look at those examples at the bottom right. Bio-inspired robotics, machines that move and adapt like living organisms. Humanoid AI, robots with human-like form and behavior. Physical systems, AI controlling machinery, manufacturing, and logistics in the real world. Sensors and chips, AI embedded directly into the physical environment, able to see, hear, feel, and sense the world around it. This is a profound shift. AI is no longer just reading about the world from behind a screen, it is stepping into it. It can now perceive reality through cameras, microphones, and sensors, and act upon it through robotics and physical systems. The boundary between the digital and physical world is dissolving, and that opens up possibilities and challenges that we are only beginning to understand. And here it is. Everything we have covered in this course so far, brought together in one single diagram. Take a moment to look at it because this slide is the map of everything we have been building towards. The big picture, two sides of the same coin. On the left, you have human intelligence with its three layers we know well by now: analytical, cognitive, and generative. And on the right, you have artificial intelligence, structured in exactly the same way: analytical for data, cognitive for decision, and generative for creation. And right in the center, connecting both sides, is the process: personal or business, making your bed, applying for a loan, diagnosing a patient, designing a building, approving a credit application. Humans accomplish processes using their intelligence. AI automates, augments, and improves those same processes using its intelligence. That is the relationship. That is the entire story of this course captured in one diagram. AI is not here to replace the process. It is here to make the process faster, smarter, more accurate, and more scalable than any human could achieve alone. Now, let's talk about foundation models, because this changes everything. Cast your mind back to how AI used to work, not so long ago. Every AI system was built for one specific task. You wanted to detect spam emails? You needed a model trained specifically on thousands of labeled spam and non spam emails. You wanted to diagnose tumors from x rays? You needed a completely separate model trained on thousands of labeled medical images. You wanted to predict stock prices? Another model entirely, trained on financial data. Every single task required its own dedicated model, its own massive data set of labeled examples, and its own expensive and time-consuming training process. It was powerful, but it was rigid. Each model knew how to do one thing and one thing only. Ask it to do anything else, and it was completely lost. Then foundation models arrived, and they changed the game. A foundation model is trained on massive amounts of unstructured data, such as text, images, code, audio, and video. Instead of relying only on carefully labeled data sets, these models are often trained using unsupervised or self-supervised learning, where the model learns patterns, relationships, and representations directly from the data itself. This is what makes foundation models so powerful. They can scale across enormous data sets, generalize beyond the examples they were trained on, and support more than one task. Rather than building a separate model for every single problem, a foundation model provides a broad capability base that can be adapted through prompting, fine-tuning, or tool integration. In simple terms, earlier AI systems were often designed as specialists for one task. Foundation models are different. They are general purpose models that can be directed toward many different tasks and domains. Foundation models are powerful because they are trained on large amounts of data and can perform many different tasks. However, in most real-world applications, we do not use a foundation model exactly as it is. Instead, we usually build on top of it using techniques such as prompting and fine-tuning. Prompting is the simplest and most flexible way to guide a foundation model. A prompt is the instruction or input we give to the model to tell it what we want. For example, we might ask the model to summarize a document, classify customer feedback, write code, or answer a question. By changing the prompt, we can change the model's behavior without changing the model itself. In other words, prompting is like giving the model clear instructions at the time of use. The foundation model already has broad knowledge and general capabilities, and the prompt helps direct those capabilities toward a specific task. Fine-tuning, on the other hand, goes one step further. Fine-tuning means taking a pre-trained foundation model and training it further on a smaller, more specific data set. This helps the model become better at a particular domain, task, writing style, or organizational context. For example, a foundation model might already understand general medical language, but if we fine-tune it using clinical notes, medical guidelines, or hospital-specific documents, it can become more specialized for healthcare applications. Similarly, a model could be fine-tuned on legal documents, financial reports, customer service conversations, or educational materials. Now look at the bottom left of the slide. The hierarchy is clear. Generative AI is the broad capability. Foundation models are the large general purpose systems that embody that capability, and large language models, LLMs, are a specific and extraordinarily powerful type of foundation model focused on natural language. Here are some examples. ChatGPT is powered by a foundation model built on text. It has read and learned from an almost incomprehensible volume of human written content. And from that, it can write, reason, summarize, translate, code, and converse across virtually any topic. Dolly is a foundation model built on images. Show it enough images paired with descriptions, and it learns the deep relationship between language and visual content, allowing it to generate entirely new images from a simple text prompt. GitHub Copilot is powered by a foundation model built on code. AlphaFold is built on protein structures. Each one has learned the fundamentals of its domain at such depth that it can operate flexibly and creatively across an enormous range of tasks within it. Now, I hope you have a clear understanding of what artificial intelligence is. If you're interested in exploring this further, you can check out the full course From Intelligence to Artificial Intelligence. That brings us to the end of this section. If anything is unclear, or you would like to explore any of these ideas in more depth, please feel free to ask your questions.